This lesson we'll be looking at what's called the chain rule, and the chain rule states that dy dx is equal to dy du times du dx, and the easiest way to show you how the chain rule works is actually just to work through an example. So let's jump straight into this question here. Find the derivative of y equals 3x plus 4 all to the power of 20. Now we've seen that we're able to differentiate questions like this if the power is small. If we had 3x plus 4 all squared, we could expand it and then find the derivative. But when we've got to the power of 20, that process would become much too involved. So this is where we use the chain rule. What we need to do is let u equal this component here in the bracket, so 3x plus 4. And then we'll end up with a y, our y being equal to u to the power of 20 because we've let u equal what's in the brackets there. Now with that, we need to find the dy dx for the chain rule equals dy du times du dx. So this first component here, dy du, we need to differentiate this with respect to u. So y equals u to the 20, differentiate that with respect to the u, we'll get 20 u to the power of 19 times du dx. We differentiate this here with respect to x, that'll just give us 3. So we're left with 60 u to the 19. Now we need to substitute back in what we defined our u as. So that'll give us 60 3x plus 4, that's what we defined our u as, to the power of 19. So that's the chain rule for you. Let's jump into another question here. Alrighty, this question here, question 2, says differentiate y equals 4x cubed minus 5x all to the power of negative 2. Now again, this is a chain rule question, so we need to define our u. Let's let u equal 4x cubed minus 5x, so just that component in the brackets, and that will give us y equal to u to the minus 2. So if we go ahead and apply the chain rule, we'll get dy dx equals dy du times du dx. If we differentiate y with respect to u, that will give us minus 2 u to the minus 3 times du dx. So this here, differentiating that with respect to x, will give us 12x squared minus 5. Now what I'll do is, just to make it clear, put that minus 2 over u cubed, so that we're dealing with the positive power times 12x squared minus 5. And let's just tidy it up by substituting our u back in. So we defined our u as 4x cubed minus 5x. So this will become dy dx equals minus 2 times this here, 12x squared minus 5, all over u cubed. So 4x cubed minus 5x, all cubed. Alrighty, let's have a look at one last question. Alrighty, this question is asking us to find the gradient of the curve with this equation at the point 1, 4. So what we need to do is go ahead and use the chain rule. Let's let u equal what's in our denominator here, 3x squared plus 1. Let's make our y then equal to 16 over u, and just to make that easier for us, that's y equals 16 u to the power of minus 1. Alrighty, let's use the chain rule. dy dx equals dy du times du dx. Dy du for us will be, we're differentiating this here, y with respect to u minus 16 u to the minus 2 times du dx, we're differentiating this with respect to x, so that will give us 6x. If we tidy that up, we will get minus 96x u to the power of minus 2. And if we substitute our u back in, our u was 3x squared plus 1. So let's make this minus 96x. What I'll do is I'll write it to the power of positive 2 as well. So that was 3x squared plus 1 all squared. Alrighty, but this question is actually asking us to find the gradient of the curve at the point 1, 4. So in order to find the gradient at the point 1, 4, we need to substitute x equals 1. So at x equals 1, dy dx equals minus 96. Substitute that 1 in there. All over, we'll get 3 times 1 squared plus 1 all squared, which will give us minus 96 over, that'll be 3 plus 1, 4 squared, 16, which equals minus 96 divided by 16 equals minus 6. So we can say, therefore, the gradient at x equals 1 is minus 6. So hopefully that's been a helpful introduction to the chain rule for you.